Okay, we're going to test this for lab number 10. We're doing the solar lab. I finally got my voice back, so we'll see if this video comes out any better this time. First of all, we're going to go over and get the assignment. So we're just going to go over to Canvas, log in, and go to 360, of course. Then we'll come over here to modules, go to the week we're in, go to lab number 10. We're going to download that, open it up, and choose Enable. And then the whole purpose of this assignment is to get you to be familiar with 3 different websites. One of them is PVwatts by NREL. And what it does is it actually gives you it actually records data on the amount of sunlight that's being absorbed at the different surfaces in the world. And so if we enter our address, it'll tell us what the average sunfall is in that particular area. Basically, it'll give us our sun hours. So we'll go to that one here in a minute. Well, actually, let's go to it right now. We'll check it out. So if you, these should be linked. So if you hold the control key down and click on them, should open them up. So this is what it looks like. We're going to choose Fort Collins, Colorado. Just go, and it should choose this latitude and longitude, 40.57 by minus 105.1. That's close enough. Again, if you get something slightly different, your numbers may vary slightly, but not too bad. So we're going to click the next button here. Now what we're going to do is we need to know the DC system size. Well, if we go back to our assignment over in Word, we don't have a DC system size. All we have is it says that the average is 850 kilowatt hours per month. Well, that's AC, not DC. So what we'll have to do is we'll have to do some calculations with that and say, well, what is our total yearly AC value that we would get? And so we would bring up our calculator on our phone here. It would take 850 times 12, and we're going to get 10,200. That would be the kilowatt hours per year that we would get. If we come back over to our PV watts here, we'll see that with a DC system size of 4 kW, if I click on the button here, it's going to produce about 5,846 kilowatt hours per year. We need 10,200. Okay, so we would have to increase that DC system size. So if we went 7.8, something like that, I don't know, we would get 11,400. So you can kind of see how that changes. So DC system size is different than the AC that you're going to use. Okay, well, what else can we change here? Well, we can change what kind of modules we're going to use. So typically we're going to stick with standard modules. Okay, what kind of array type? Well, we're assuming this is on a residential house on asphalt shingles on a roof that has a 612 pitch. Okay, so we go back to our assignment, 612 pitch. It tells us the house runs east and west, so we got a nice south-facing side that we can put them on. So that's what all that information tells us. So we're going to go here, we're going to go fixed roof mount. Okay. System losses. We're going to keep the system losses where they're at. If you want to see how they calculated and came up with the 14.08%, you can click on here and it'll tell you soiling, shadowing, snow, mismatch, whatever. Again, here, if we have a snow load or if you're in some place that have a lot of snow, you may put a percentage on there for the number of times or the percent that they would be covered by snow. But we're going to leave this at the default at about 14.08%. Okay. Tilt angle. Well, what's our tilt angle? Well, it's 612 pitch. I don't know if you know what 612 pitch is in degrees, but if you don't, doesn't matter. We'll use a little information symbol here, and it tells us that 612 pitch is 26.6 degrees. So we're going to enter that in here, 26.6 degrees. And then azimuth, 180 degrees. Well, ours is facing south. Okay, well, which direction is south? Well, north is 0, south is 180. But if you don't remember that, click on the little information thing. It'll show us that north is 0, south is 180 degrees. So we're going to leave it at 180 degrees. Okay, those are the basic parameters you need to enter. And then what you're going to change again is you're going to change this DC system size until you get an AC output that is just a little over 10,200. So you can see we're a little hot, a little too much. So let's go back to 7.2 and a little more, maybe just 7. And you can see that's probably close enough, 7 kW system. We always want to be slightly over. We could probably tweak it a little bit if we wanted. Now, I wouldn't go more multiple decimal places here. One decimal place is fine. I wouldn't do multiples. And so that's not quite enough. 6.9. Again, not quite enough. So I think I kind of settled on 7 kW for my system size. Gave us just a little over 10,200. Okay, again, close. We're just approximating right now to see what approximate DC system size that we would need. Okay, once we have the DC system size, then we'll use that to calculate how many panels we're going to need to get that DC system size. Okay, down here, this is just if you wanted to see what kind of payback on your electric you do. Choose whether you're going to do residential or commercial. Typically in Fort Collins, I told most of you to go home and look at your electric bill first lecture of the semester. Those that did probably found out that in Fort Collins, the electricity is somewhere between 11 to 13 cents a kilowatt hour. So we're going to put 0.113 in here for 13 cents a kilowatt. And then we're going to click here and see that if we generated our own electricity at our 13 cents a kilowatt, you can see kind of the solar radiation, basically the sun hours per day that we're going to get, the amount of energy we're going to generate each month, and then what kind of dollar value that would have. So basically, we're going to generate about $1,344 worth of electricity per year. Okay. Again, this is going to just tells us the data of everything we've entered and so forth. Okay. So that's what you use PVwatts for. Other thing you'll use it for is if for some reason our house doesn't have a south-facing roof, and so if you look in the assignment, back in the assignment over here, you'll say, well, it says what happens if the size of the array, to the size of the array, if the house happens to run north and south, and we mount the panels on either the west or the east side. Well, we come back over to PVwatts, and we're going to change this azimuth. So we can see that east would be 90 degrees, west would be 270 degrees. So let's put in 90, make sure it checks the green. Come here, and we can see that 7 kW system now is no longer big enough. So we're going to come back here, and we'll change it to an 8 kW system. Still not enough. Okay, again, go 8.4. All right, so 8.4 is a pretty good number. So we need 8.4 kilowatts of DC power to equal 10,317, which is just a little over 10,200 that we're looking for. Okay, so we can face our panels east. It's just going to take more panels to do it. Okay, let's go west. West again was 270. So we're going to change this to 270. So let's remember that 8.4 while we're at it. So we got 7 kW for south, 8.4 for east, and then we got west. Make sure you check the check box. Let's go 9. I don't know what it is off the top of my head. It's been a whole semester. 9 kW, pretty good guess, right? 9 kW, so we're going to do 9 kW for west, okay? Now, what do we do with those numbers? Okay, so we're going to come back over to our lab, and we're going to go over to this web store. So Alti web store, click over here, and these change the panels and stuff that they have change all the time. So I went to the website, I went to solar panels, and then here I'm going to choose to sort them by dollar per watt, because I want to sort them by the cheapest panels, so the panels that give us the most watts for the cheapest dollar, okay? And I know the lab over here, the lab said to use the Q310 cell. Well, they don't want to sell that one, of course. It's been a whole semester that changes all the time. So what I'm going to have you do instead is just choose whichever panel is the cheapest per dollar per watt. Okay. So we come back over here. It happens to be the Q cell 345 watt poly. It happens to be 50 cents per watt. Again, it's 245 watts of DC power. Okay, so what are we going to do? We're going to take our 7 kW, which is 7,000, and we're going to divide it by 345. Okay, so if we do that, I'm going to do it on my phone here. You guys can do it at home on your phone. We're going to do 7,000 divided by 345, and we're going to get 20.28 panels. We're always going to round up, okay? So we're going to get 21 panels that we would need if we were doing facing south, and to get our minimum of 10,200 AC watts using a 7 kW DC system, okay? So that's how I determine how many panels I need. Oh, excuse me. Allergies are wonderful. I lost my voice for a while there, so that's why I hadn't recorded a video. Turns out when your sinus cavities are all plugged up that these aftershock headphones don't work very well. Anyway, onward. So now let's calculate how many panels we need for going east. Well, for east, we got 8.4 kW. So we're going to put 8,400 watts divided by 345. That's the size panel. And we're going to need 24.34 panels. Again, we always round up. So we're going to go 25 panels if we're facing east. Okay. Then for facing west, we needed 9 kW system. So 9,000 watts divided by 345. Would be 26.086 panels. Again, we're always rounding up, so 27 panels. Okay, so that's where you're going to come up with the number of panels. Okay, does that make sense? Hopefully. Now, we need to get the electricity to go from DC to AC. Okay, so we need what's called an inverter to do that. So if we come over here and look under inverters, we have some different types. We have off-grid, we have grid-tied, we have microinverters, hybrid inverters, and so forth. Okay, off-grid inverters are designed to take your DC and go directly to AC, but there's no backup. You have no grid to back up for when you're not producing enough electricity. Okay, they also typically include a charger, DC charger. Well, let's go click on one. We'll go a big one. So we'll click on one. So you can see that most of the time it includes an inverter plus a charger to charge the batteries. Because again, you have to have some way to store the energy during the day so that you can use it at night. Okay. We're going to actually look at microinverters. Okay. So these are a grid-tied system, but they're microinverters in that you bolt them to the back of the panel, okay? So you're going to use one per panel. You can watch her little videos here. You got to love her hair in her videos. But we're going to use just this, we're going to use this IQ7, and we're going to use this new module here, this IQ7A It's good for 366 watts. We're going to use that one there for $179. So use that one instead of the one I had listed before. What one did I have listed before? Let's go back here. I had IQ7 Plus 295 watt one. Well, they have the new one. This is a new one that just came out for 366 watts. It's going to give us a little bit more power, especially since we're using a 345 watt panel. Okay. So again, use that one. Use the Enphase IQ7A 366 watt panel. If you want to know more about it, you can click on it. Under Documents, you can go ahead and read the data sheet here. Tells you all about it. What range, commercially used module pairing. We can go 395 watt all the way up to 460 watt panel. We're going to use a 345 watt panel. So it's going to be really good. It's a pretty good match. Okay. Pretty good efficiency. About 97% at 240 volts is what we will be for residential. Okay. So let's go ahead and close that. All right. So that's the panel we're going to use. Okay. So we're going to build a pricing sheet for each case. Okay. So we're just going to jump into Excel spreadsheet. Okay. We're just going to create a blank worksheet. We're going to come in here and we're going to type south. Okay, for south facing, and we're going to do 345 watt module. 345 watt module. So this is our module. Module. Okay, then we need our inverter. Inverters. Okay, we're going to do that IQ7A inverter. So that's what we're going to use. Okay, so however you want to arrange it, we need to know the number of modules and so forth. So I'm actually going to probably move some of this stuff around. Probably format a little differently. Been a whole semester, you know. I'm going to do my modules. I'm going to do 345 watts. I'm going to choose the number of them. So if I'm doing the south facing, I'm going to have 21 of them. I'm going to do my inverters. I'm going to do inverters over here. And I'm doing the IQ7A. And I'm also going to need 21 because you need one module for each inverter. Okay. And then I want to come over here back to my pricing sheet. Do I still have that open? I do. $179 for the inverter. And if we go back to the solar panels, dollar per watt, $173.88 for our solar panels. Let's see if I can remember that long enough to go back and click on them. So 173.88 and $179. Okay. So we can format these for dollars if you want. Format cells, currency, boom. And then we want to get a total cost. So we'll just go equals. We're going to take that times that, enter, copy, paste. Okay, should give us our two formulas. And then we're going to just do our auto sum. And that would tell us our cost of our system for south for the modules and the inverters. Okay. And now we need our mounting hardware. Okay. Now this particular website, again, they change it every semester. So I have to go make sure it works. Well, I didn't go make sure it worked because I've been feeling like crap. But let's go over here. We're going to go, I know the link is broken, but if you click on the link, come on, it will take you over here. All you got to do is take the tools off, get rid of the tools, and it'll take you to their website. Now, you have to log in or you have to create a login nowadays. You didn't used to when I first started using this website. So again, all you got to do is register, create a login, so forth. I already have a login, so once you've got a login, you get logged in, then you're just going to create a new project, okay? Where I'm just going to go flush mount, and then I'm going to design mine on a blank piece of paper, okay? Instead, if you wanted, you could actually go zoom in on your house, and you could create it with your house. All right, so we're going to choose our module. So we did Canadian Solar. Is that what we did? PVwatts. Yeah, we did Q-Cell. Who's Q-Cell by? Is it by HANA? Yeah, yeah. So this is what we're looking for. HANA Q-Cell 345. Let's see if they have them in there. I don't know whether they do or not. I haven't looked this semester yet. Yeah, so HANA, and then we want our Q-Cell 345. I would go in here until I just find a 345 watt panel. Q cell. I don't know. Did I pass it? I probably passed it. Q plus 310, 315. Now 345 right there. So just choose a 345 watt panel, which is fine. We're going to save changes. We're going to put in our zip code, 80523 is the zip code at school there. And what that's going to bring it is going to bring our building codes in. It's going to bring our basic wind load speed, our ground snow load, and so forth. So all our seismic factors, whatever that is. What that's going to determine is the number of mounting points, how many attachment points to the roof we need, and so forth. What kind of rail structure and so forth. We're going to go save. We're going to just use the standard rails with a maximum of 16-inch cantilever. So use those. We're going to do east-west rails. Typically, cheapest to do east-west rails. Depends on your roof, what kind of roof you have. If it's a real steep roof, long axis up and down, then you may be better off with north-south rails. But typically, we don't have as much vertical rise. We have more horizontal. So typically, our east-west rails typically come out cheaper. Okay, we're going to hit Save Changes, and then now we're going to create a roof area. So we're going to create the roof area. First thing we have to do is enter the pitch before it'll let us do anything. So in here, this case, the 612 pitch is what it has, and we're ready to start designing on our roof. So we click on this, and you can literally drag like this, and it will add panels for you, okay? Now, in the first case, I need 21 panels. I just got lucky and it put 20 panels on there when I clicked, and then I can add another one, okay? So I have 21 panels. It says I have 7.245 kilowatts. Again, I needed a minimum of 7. Remember, we rounded up on the panels, so instead of 20 point some panels, we have 21. So again, that's a good number. That looks good, okay? If you put too many panels, you can click here and you can subtract a panel, or you can click here and you can add a panel, okay? It's that simple, okay? Once we're done adding our panels right here, all we're going to do is either hit continue down here, or you can just go click to the parts list. So hit continue, the gears go here, and it figures out all the parts you need to mount it to the roof. It's going to give you your total price here. That's really all we're looking for, is that total price right there, whatever you come up with, $824.41, okay? And so we're going to jump back over to our Excel spreadsheet, 824.41. We're going to go, I'm just going to label this as my mounting hardware. We come over here, 824 point, I don't know, what was it? 41, 824.41, 824.41. 41, all right? And then I'm going to do another auto sum. This time, drag that corner there. And so for my south facing, I'm going to get a total cost of $8,234.89. Again, that's no labor in there. We're assuming you're doing all the labor yourself. That's the modules, the actual solar panels, the modules, the inverters, the mounting hardware. We still got to add labor, and we still got to add the wiring. Okay, so there's some trunk cables and so forth, breaker box or a breaker to go on the breaker panel, and maybe a cutoff switch depending on your local code. Okay, but that's basically what I want you to do. Now you're going to do east, and then you're going to do west. Okay, you can put them on separate tabs, like I said in the document, or you can put them all on the same tab. I don't care. All I'm going to be looking for is kind of these numbers right here to see if you got close to what I got. For east, the difference would be we're going to use the same modules, so I'm actually going to just copy this. Copy, click right down here, and go paste. And so the difference is instead of 21 modules, we're going to use 25. So I'm going to click 25 here, 25 here, those updated. And now my mounting hardware, I need to design it for 25 modules instead of 21. So we come back over to our view builder here. We go back to our design. And we should be able to edit our design here. And right now I have 21 panels. I'm going to drop in 25 panels, okay, instead of 21. So now I'm going to hit continue. It's going to recalculate by bill of materials, and it's going to give me a price of $1,029.41. $1,021.49. See if I can remember that number. So I could probably 1,029.41, stick it in there, and now I have my new price for east facing. Okay. Again, you guys are going to do the west facing just like that. Okay. Hopefully that makes sense. Sorry it took me so long to get this video out. This is the second time I've recorded, but hopefully it came out a little better this time anyway, and hopefully the volume's good. All right, so click back over here.